Welcome to the Software Process and Measurement Cast number 648. I'm Tom Cagley, your host. Today, Alex Omeyer and I discuss defining, tracking, and measuring technical debt. Technical debt generates a liability that every organization must deal with. Alex states, tech debt might not be the sexiest topic, but if teams and organizations don't address their liabilities, it will be difficult to deliver the value customers need and expect. We also talk about the practicalities of pivoting life ambitions and entrepreneurship. Alex is the co-founder and CEO at Stepsize. Alex states, I personally spend most of my time speaking to the best software development teams in the world about how they handle technical debt. Hit me up to talk about technical debt. I love to share what they taught me. Alex and his co-founders are building Stepsize, a free tool for engineering teams to track and prioritize technical debt. Stepsize's mission is to make software development more accessible, efficient, and powerful. Are you ready? Put a down payment on technical debt? It's time for the interview. Alex Omeyer, welcome to the Software Process and Measurement Cast.
Thank you for having me, Tom. Glad to be there.
Today, this topic of technical debt has been around for a long time. And obviously, since we've gotten into the agile era, it's become popularized. Probably existed before. But everybody seems to have their own definition. Can you put your spin on it?
Yeah, I know. I think most popular pieces of content are the ones that lead people to debate about the definition of technical debt. It's a thing that engineers love to geek out about. I do too, but I've decided to go or work with a fairly general one. We define technical debt as any code that you've decided is a liability, whether it be because it's hard to understand or it's too complex to modify or it's causing bugs in your system or UX problems for your customers. It's technical debt. Doesn't matter what the impact of it is. It's technical debt.
Every once in a while, you'll see me take notes, and this is why I'm glad I edit. It's like, ooh, that's good. Any code that's a liability is technical debt. I mean, I think the word liability really is sort of a loaded word, right? It says that it's bad. So obviously the obvious question is to ask why we care about that. But so if the idea is this stuff is bad, I mean, obviously we could just ignore it. Is it bad because it creates an economic drain? Why is it bad?
Yeah, I'll take a step back to answer that question and sort of give a bit of extra context. Technical debt in and of itself is not a bad thing. The reason I say this is because you can use it to gain extra leverage. So you can say, we want to ship this software, but we don't exactly understand our users' needs. We're pre-product market fit, for example. Let's take a few shortcuts to get it in front of users and we'll come back to deal with it later. That's fine. That's a thing that organizations do and should do, because until you get to that phase where you clearly have product market fit, you're most likely going to end up throwing away 90% of your code. And that's the best way to deal with technical debt, throwing away code. But you don't always have the luxury to do so, right? You might have a product that's used by a lot of customers that you now have to maintain. And that's the point, is whenever you ship any line of code, there is a cost that you're going to incur in that you need to maintain that code. If you do it well, if it's still appropriate to the problem you're trying to solve, for example, I wouldn't call it technical debt. It's just a fact of life. You ship code, you have to maintain it. Now, problems start happening if you take on technical debt recklessly and without being properly aware of it, right? So deliberate and prudent technical debt is fine. Reckless technical debt that you take on unconsciously is not fine. And the reason it's not fine is because you end up in situations where your engineers are extremely unhappy because they can't ship the features they want to ship on the code base. It is. You end up causing bugs for your customers. You end up having a lot of errors and outages in your systems. And the root cause to all of this stuff is the technical debt in your system that you can't even identify, right? Because you took it on unconsciously and recklessly.
I'm hard pressed, and having spent a few hours of my life coding, I think I know occasionally when I've made or created a shortcut that might be conscious technical debt. I am not convinced that I know how much that I left behind that was unconscious, not deliberate and prudent, to use your words. How do we know?
Yeah, that's a great question. Here's the thing as well with technical debt is that the best engineers in the world, even with, the perfect understanding of the problem they're trying to solve, will still introduce some technical debt. The reason being, when you start building software, you obviously build it based on your understanding of the problem at hand, your current understanding of that problem. And as time goes by, your understanding of that problem evolves, but your code doesn't, unless if you do something about it. And the way you figure out what to do about it, there are a bunch of ways to do so. First of all, speak to your engineers. They'll know where the technical debt is for sure. All of this stuff lives in their heads. Then there are a bunch of ways in which you can sort of see clues that you might have technical debt in your code base. There are tools that help you find low quality code in your code base, right? Things like Code Climate or Codacy that will tell you this function over here or this file is very complex. The code is highly indented. It's very obtuse, right? And that is like sort of, red flag, a bit of smoke telling you should have a look in this part of your code base, see if there's some technical debt. The next thing is, and that's what Stepsize does as well, is you remember how I mentioned that a lot of this stuff lives in the engineers' heads. You need to find ways to get this out of their heads into a system that allows you to visualize and consume this information properly. And I'll give you a quick overview of how you might do that. We built a tool that allows engineers to report tech debt directly from their workflow. So when they come across it, when they're shipping features in their day-to-day, they'll be able to say, this thing here is a piece of debt. Here's why. On top of this, they'll be able to say, here's the impact of that debt on the business. Right? So I just spent 3 hours debugging this thing. It's the third time that we debugged something like that. This customer was impacted. We have all these errors piling up in our logs, and I found the root cause of that problem. It's this technical debt here, right? So that's how broad categories for finding your technical debt. Speak to your engineers, use tools that look at code quality and maybe metrics from your version control tool, so Git usually, and then use something like Stepsize. They'll extract what lives in the head of your engineers, put it in a way that's easy for you to consume it.
We know that there's tech debt there. Why don't we just immediately refactor it? Just that It shouldn't be there. Let's just get rid of it.
Yeah, that's a great question. And that's the challenge. Fixing technical debt calls upon the same resources that you might use to ship features, engineering resources, right? If you plan your sprint, a lot of teams will say we'll spend 20% of our time dealing with technical debt. And what's implied is the rest of the stuff will be spent shipping features. And the challenge here is that it's really easy to draw a straight line from shipping this feature to revenue, or whatever it is that your key goal as a company might be. And it's a lot harder to do for technical debt. Typically technical debt is this hazy thing. It's hard to draw a line around. It's hard to measure the impact it's had on the company. It's hard to predict how much of a problem it will be in the future. And so it's a lot harder to make the case for this. Dealing with this piece of debt will move the business forward versus dealing with this feature will move the business forward. And so that's what you want to uncover, and that's the riddle that you want to solve with this process and tooling that I mentioned earlier.
I guess I'm hard pressed. I talked to a person. Actually, the first person that I ran into, and this has all been in the past few months, that called code a liability. In essence, his argument was all code was liability.
Yeah,
but from that point of view, if we know we have a liability, making that decision, how does someone get to a point where they know it's time to actually deal with the pile of technical debt, even if it's all been consciously and prudently decided that we're going to make these choices? At some point, either you pay somebody back or they come and, take stuff away from you.
Yeah. No, I'm glad you asked this follow-up question. So first of all, yes, the argument could be made that the moment you ship a piece of code, it's technical debt. I've heard it made before. It makes sense. I guess you can't boil the ocean, right? You can't say we're going to spend the next 6 months or the next year rewriting our code base or refactoring everything. You've got to make decisions about what you start with. And there might be parts of your code base that are absolutely terrible to work with, but you know what? They're not causing any bugs. They're not causing any outages. No one's going to be working on it in the next quarter because our roadmap doesn't have us working in this part of the code base a lot. So I'm going to put this one aside for now. I'm going to keep an eye on it because it might cause problems, but I'm going to set it aside. On the other hand, if you pick up your product roadmap and you look at what you're going to ship in the next week, quarter, year, you should be able to tell which parts of the code base you're going to spend most time in. And if you have your technical debt neatly tracked and you've measured the impact it's had in the past, you'll be able to say, these are the pieces of debt we should prioritize because we're going to clear the track ahead for all the features that we're going to ship, right? We don't want this to be even more of a problem when we're trying to execute on our feature roadmap. And that's what a technical roadmap is effectively, is you create a technical roadmap that will enable your feature roadmap. Does that make sense? Does that answer your question?
Yeah, it does. I mean, what you're describing is really having an approach to technical debt that's almost technical debt as part of your direct strategy of bringing product to market.
That's right. It's effectively, the way I like to think about it is you might categorize different pieces of debt into 3 categories: small, medium, large. The small piece of debt is one that, so there's this rule in the industry about being a Boy or Girl Scout, right? You leave the camp better than you found it. These small pieces of debt, the engineer should just be empowered to fix them right then and there. You don't need to have it go through any kind of planning process. They see it, they fix it. Then you have the medium piece of debt, which is one that if you were to fix it would take maybe a sprint. It fits within a sprint. And you should have these pieces of debt go through your normal agile sprint planning process, right? They should be considered just as carefully as you might consider feature work. And then you've got the large pieces of debt, which is anything that can't be fixed in a sprint. Maybe take a quarter or more. Think about upgrading from your old version of Ruby that impacts like every bit of your application. And for this, you need to have a process where engineering and product leadership evaluates different pieces of debt, maps them onto a roadmap, and then it gets scheduled onto that roadmap as technical work that gets completed ahead of your feature work. And if you manage to do this, which is effectively continuously addressing debt as you're shipping features in your day-to-day, you'll have a great handle on it and you'll ship better software faster. That's what it's all about at the end of the day.
So just sort of the prerequisites that I'm hearing is you have to have a strategy for dealing with technical debt. Probably have to have an approach, strategy and approach, probably not the same thing. And then you have to know where it is. Other than that small stuff, which probably don't, if it's being dealt with, on a common basis. One could make an argument that at some point you really want to know if it's cropping up over and over and over again.
Exactly.
In the short run, you probably don't need to know a whole lot more about that than that.
Mm-hmm.
How do tools like Stepsize get you to that?
Yes. I really like your point about how small problems aren't that big a deal up until the point where they get repeated over and over again because they add up to something big. That's precisely why we've been so careful to integrate with the tools engineers use every day to allow them to report all these instances of debt. So that's one component of Stepsize, is we've made it super easy for engineers to report tech debt they come across in the code from their editor, say from VS Code, in the code review. So from GitHub to say, look, it's not within scope to fix this piece of debt here, but we shouldn't sweep it under the rug. Let's save it into Stepsize. The same, you can do the same from Slack as well. A lot of teams tend to have all their, say, code quality tools, APM tools, logging tools, pushing notifications into Slack. And if you see some that come up that are effectively symptoms of technical debt, you log them into Stepsize. So that's step one. Step two is when you're tracking this debt, you're slowly building up a picture of where it is and how much of an impact it's had on the company. So we have a web app where all this data gets organized based on the domains in your code base. And the domains, they might be things like authentication, the payment service, this or that feature. They're the bits of your code base that the language that you use to talk about the different bits of your code base. And then the next step will be, okay, I've identified the debt that has the biggest impact on the company. I know what's coming up on my roadmap, so I'm going to decide what to fix. And we've integrated with Jira, the project management tool, to be able to surface that technical debt automatically so that you can clear the debt that's in the way of the feature that you're about to ship, right? And once you've tracked the debt, measured its impact, prioritized it, you started fixing it, we created KPIs for you to be able to track how much progress you're making at addressing this debt, right? So these are the pieces of debt that were marked as resolved, they're dealt with. This is how much of an impact they used to have on the company that's now cleared. And you can build your system around that, if you will. So it's not just a product, it's a process to go with it that fits within your existing tools and processes that you use to do the whole agile development thing. That's how we think about it.
I think all tools have quote unquote an opinion, and that opinion impacts on process. How heavyweight do you see your tool? I mean, how much of, to use a friend of mine down the street who's an economist, he'd call that a negative externality, right? Something that instead of, taking the time to do all this is not shipping product. How much of a negative externality is, dealing with technical debt by logging it and understanding it? Or do you see it as the exact opposite? So something that actually enables delivery?
Yeah, that's a great question. So I think first we need to establish what we're going to compare this time investment to, if you will. Like, what happens if I don't deal with technical debt? And I'll use a couple data points from sort of other industry experts that looked into this. So Stripe, the payments company, did some research where they found that engineers spend about a third of their time dealing with technical debt, whether it be because of the consequences of that debt or whether it be because they're fixing it. And on top of that, there's a next half to that quote, which is technical debt is the number one reason why engineers end up miserable at their jobs. They just want to ship code and build stuff. They don't want to spend the next 2 months figuring out how to update the footer on the website. So they will leave companies that have too much debt, right? That's one thing. And then you need to know what happens if you have a good strategy in place to deal with tech debt. That data comes from Gartner. They did a lot of research with larger companies who, during the pandemic, had a bit of time to start figuring out how to maintain their code base. And they found that the large companies who have a strategy in place to deal with debt, not just, the best strategy, a strategy, ended up delivering software 50% faster. So that's what you're comparing it to, right? Not doing anything, but doing something about tech debt. Now, I'll tell you about how we onboard a new customer so that what time investment is required. I think it's the best way to look at that. People typically go through our content and learn about the process to deal with debt. And small, medium, large debt, this process that I told you about, we didn't invent anything new. This is how the best teams that I've spoken to deal with debt. We just built a product to go with it. So this is a tried and tested method. Now, so they're already doing that in some shape or form, right? When they get in touch to get started with Stepsize, we schedule a half-hour call to give them a demo. We record the call. They show it to their team. They say, let's go. We schedule a 45-minute kickoff call to show them how it works, and they're off tracking technical debt, right? They get a 1-month trial. They report debt as they do their work. They maybe do a spike to track the debt that's in the most pressing upcoming project that they have. We check in once in the middle, we check in once at the end, and they're off to the races, right? And that was really important to us in how we developed the product. Engineers just don't adopt tools if they're too complicated, and companies aren't going to change their habits to adopt a completely new process if it doesn't fit into the way they're used to working. So we were really careful with that. Does that answer your question?
Yes, it most certainly does. When we had our pre-call to discuss doing this, one of the stories that you told me was that this was not where you started. So I'd like to hear a little bit about the entrepreneur's journey and the pivot to this versus where your ultimate goal might be.
Yeah, I'll try to give you the short overview because there's a long story here. For context, I have three co-founders, all of whom are mathematicians and data scientists, on top of being software engineers, designers, and good product people. So I'm well surrounded with a lot of data nerds. And in the summer of 2015, with actually my brother started messing about with that. Who's my brother Nick is one of my co-founders, right? At the time, there were people who were using neural networks that they trained on Shakespeare's work to try to produce some new and original Shakespeare. And it was, obviously it was nonsensical, but it looked a lot like Shakespeare. But that's what seeded our big idea, because Nick thought, would it be possible to apply these same kinds of technologies to code? Code as a language. We're talking about generating language. We're talking about translating languages. Let's have a look and see what comes out the other end. And we got all the code, the Python Flask code specifically, I remember, that we could get from open source projects on GitHub and on Stack Overflow. And we trained the model and we gave it the beginning of an endpoint in Flask and we asked it to generate the rest. And we were so excited when it did. It wasn't functional, but it did. It looked a lot like Python Flask code, right? And that sent us down this rabbit hole that was like, hey, there's all this data that people create when they build software. We have new AI and machine learning technologies to do all sorts of cool stuff. Would you be able to apply these technologies to help people build software? Specifically, could you automate every bit of software development up until the point where decades down the line, you'd be able to build a system that can take, air quotes, normal human input, spoken word, written word, doodles, designs, and generate the code that goes with it, right? And so we, with that long-term vision in mind, we started thinking about what kind of tool could we build that software engineers would be using every day and would be so valuable that they would grant us access to this data set that we call contextualized code that is necessary to deliver on that long-term vision. And I'll tell you about contextualized code quickly, or at least the way we think about it. I think about version-controlled code, which is to say every point in its history. And for each of these points, all the metadata that could describe what happened to that code. So a Jira ticket that's plain English describing the intent behind the code. The data from your APM tool that's like numerical data relating to the performance of that code. And just painting that picture, every piece of metadata that could explain what's up with this piece of code. And we started working on different prototypes. I'll give you the one-liner about each of them. We first built an application that was basically a better way to do git blame. So I'm looking at a piece of code. Who wrote it? What were they shipping? And why? And let me speak to them. And then from there, we realized that the reason people needed to run git blame was because this code in question was hard to understand. I don't understand what's up with this code. I need to speak with someone. And so we built a product that we used this data that I mentioned to try and automatically document this code so they could use Stepsize to figure out what's up with it. And from there, we realized that the reason this code is hard to understand is because of technical debt. Because if code is, written perfectly well, it should be just as easy to read as English, but that's not always the case. And it's not a realistic goal either. And so we started looking at technical debt. What are the problems with technical debt? Well, it's hard to measure. So we then built a version of the tool that would sort of compute code quality metrics plus Git metrics for a given file to say, red, amber, green, this is the rating for your code. There might be some technical debt over here. Alarm goes off, have a look at it and map your code base like this. And then we realized that as interesting as this is, these metrics aren't the most actionable. I can tell you this code here is red because the ownership score sucks and it's too complex. Very few people knew what to do about it. And that's when we realized that the best source of data about your technical debt is your engineers, and the stuff that lives in their heads. And we built the version of the tool that I told you about earlier, and we're off to the races. That seems to be the way to do it.
The whole idea of being an entrepreneur, is that something that, was it, hey, I'm going to be a software engineer, or am I going to be an entrepreneur? When did those two things merge, and which came first?
Yeah, great question. This is something I might not have told you before, actually. When I was up until my early 20s, I was a professional show jumper. I used to ride horses and jump fences and shovel stuff all day, every day. And I would go to school on the side. And, sort of the idea of starting your own thing and building your own thing was quite a popular one in my family. My parents dabbled in that. My grandfather dabbled in that. My uncle did the same thing. I mean, it was just a thing that you did. You just went off and figured your stuff out at some point in your life. And here I was riding horses thinking I'd do this until the end of my life, but I injured my back. I injured my back quite badly, and I had to reconsider whether I wanted to make a career out of it. So at the time, my brother Nick and our now two co-founders were studying at UCL in the UK. I was still in Paris or just outside of Paris. And Nick and I, since we were kids, I don't know the exact moment, always had this idea that we would build something together. And I decided I wasn't going to be riding till the end of my days, and then I needed to find something else. And my ambitions were just broader. So I found a way to get myself to the other side of the channel. And I went to study a master's degree at the University of Sussex, just south of London, and got back in touch with these guys. And, I was studying management and entrepreneurship because I thought I might as well make it useful. And we started working on our side projects even when we were still students. I mean, we built little mobile apps and little websites. And at the time, none of us could write any code. So we just spent all our evenings and weekends just learning how to do that and building bad software, quite frankly. And we did that, after university, we moved in together. And again, we found jobs at different startups, but we spent all our evenings and weekends working on our side projects. And that was maybe sort of 4 or 5 years, where we honed our skills. And eventually, none of these side projects were quite exciting enough to lead us to go full time and invest the next few decades of our lives into it until we came across Stepsize. Specifically the long-term vision that was Stepsize. And, I described it earlier, but what's implied is that we happen to think that helping people ship software is the best thing that you could be doing. I look around me and I don't see a single product, a single thing that didn't involve software either in its creation or in me buying it or in it getting delivered to me. It's just the highest leverage activity that you could imagine. So we figured, well, let's go help people build software. That's a worthy way to spend the next few decades. And here we are.
Wow. That's quite the journey.
Yeah.
If you had one thing that you would have liked to have known before you jumped into the entrepreneurship world, what would that have been?
I was thinking about that when you asked me the question before so I could prepare a little bit. And I remembered some of the stuff that our mum told us. Again, so she did the whole entrepreneurship thing. She used to work in VC and private equity, so she had some great advice for us. And the one that stuck with me is that everything takes longer than you expect. It's just that's just how it is. You think that and what is it? There's a famous Bill Gates quote, I think, about this: how people overestimate what they can do in a day and underestimate what they can do in a year. And, just knowing that everything takes longer than you expect and setting this as the expectation for everyone means that we're all a lot more resilient. That this is the hardest thing that I've ever done. And it's part of the reason why we're doing that is you condense a whole bunch of life in trying to build a company in a short period of time. And yeah, knowing that it's supposed to be difficult and will take time was a good way to keep us going,
Absolutely. Well, yeah, nothing is magic and nothing is overnight. It's just, it might look like overnight, but it might have taken years to get there.
Yeah.
Alex, if you woke up tomorrow morning and somebody handed you your morning caffeinated beverage of choice and a magic wand and said you could solve any 2 problems that impact software development, what would those 2 things be and why?
So I tried to make them specific. What came to mind first was I would wave my wand and I would make it so that every non-technical person out there who works at a software company understands technical debt. The reason why is because technical debt isn't just a technical thing. It's a people problem. It's about resource management. It's about how you spend your time as a company to reach your goals. And people tend to think of it as the engineering team's problem. It's not. If your engineers, if your product owners, if company leadership isn't aligned around this stuff, it's going to be a problem. So that's what I wish I could just, snap my fingers and get it done. And the second thing is, it relates to Stepsize's long-term vision, and I touched on it a little bit. If I could simplify the whole process of building software and simplify it to the point that, let's say, 1 order of magnitude extra people get involved in building software. So instead of having 20, 30 million, we have 200, 300 million. That'd be such a great thing for the world. So that's what I'd like to do. That's what I'd like to see. I think it would undeniably be good.
Absolutely. Though it does worry me that even though software and code is such a high leverage application of time and can change the world, it still is a liability.
It is. Yeah. We've got to manage that technical debt.
The combination is interesting. Alex, if people wanted to continue the conversation, how would they go about doing that?
So you can find me on Twitter at Alex Omeyer. So that's Omeyer, and Alex, I'm sure you know how it goes. And you can see Stepsize as well at Stepsize HQ. Stepsize handle was taken, but on Twitter as well. And of course, head to stepsize.com and check out the product, sign up. I'll be glad to give you a tour. You can also go to our blog.stepsize.com and have a read through the content. I've tried my best to summarize or even go deeper into some of the ideas that we touched upon today. So if you're interested, the perfect process to manage tech debt, how you might be able to measure its impact and so on, start there. You don't even need the product to get started.
Super. Anything else that you'd like to promote? This podcast has been around for 14 years. I'm looking at about another 14 before I shut it down. So
No, look, I think I've said my piece. I'm glad that you had me on the show to talk about technical debt. I think it's a thing that gets very often overlooked. It's not a particularly sexy topic, but if we handle it properly, I think it'll do a lot for all these great people out there building the software that moves the world forward. So I've said my piece, and I'm glad you had me on the show.
I'm glad you were here too, because very frankly, there were, I filled up a page and a half of notes as we were going through here, chicken scratch in my lap. Hopefully I'll be able to read it, but there were a number of points that I think are just critically important, and I don't know that I've thought about them in that way. So again, Alex Omeyer, thank you for sharing your wisdom and knowledge with the Software Process and Measurement Cast listeners.
Thank you.
Remember, the Software Process and Measurement Cast is the proud media sponsor of the Global Scrum Master Summit, the week of May 17th, 2021. Link in the show notes. Get a ticket and plan to be there. We're also the proud media sponsor of the DevOps Online Summit, and this is a last call. The DevOps Online Summit is nearly here. It will be the week of April 26th through 30th. Tom Henricks and crew always deliver a great summit. This is the third in this series. Link in the show notes. Get a ticket and be there. In Reread Saturday News, Chapter 11 in Fixing Your Scrum, Practical Solutions to Common Scrum Problems by Ryan Ripley and Todd Miller talks about the sprint backlog. The sprint backlog is the work teams do on a day-to-day basis. If you have not bought your copy of Fixing Your Scrum, what are you waiting for? Link in the show notes. Support the podcast, support the blog, and most importantly, support the authors. In the next Software Process and Measurement Cast, we talk to Tammy Gretz. Experimentation is a dirty word in many organizations. Tammy explains how she uses powerful experiments to change the behavior and culture of people and organizations. I want to thank Women in Agile Cleveland for the great introduction to Tammy. If process improvement is a never-ending journey, why do so many people ask, are we there yet?